This video should show you how to fit with Solver. We're going to start with enabling Solver. Go to the PowerPoint presentation to make sure that you've got it turned on. You can check that by, on the ribbon along here, going to the Data tab, and it's over here on the right-hand corner. We don't need that just yet. So first thing we need to do is calculate an average and standard deviation equals average, and we've got our 3 replicates here. We can drag this data down and get an average. Same thing for our standard deviation equals stdev, selecting the replicates we want to calculate from and dragging the data down. Now, the next one is a bit more complex. We're going to be using this equation here. We've got the graph, so we can see that our y, the thing we're calculating, is v. And then on our x-axis, we have S, which is the substrate concentration, and it's here and here in the equation. So the prediction equals, remember your brackets, Vmax times the concentration, closing those brackets, new set of brackets, Km plus substrate concentration. At this stage, if I drag this down, each of those parameters is going to change. So what we need to do is include some $signs to fix the positions of these 2 parameters. If you click into this formula bar, it highlights in color which one's which. So it's much easier. We can see that we need to make purple stay the same. So we want the column and the row position to stay. And the same thing with blue. So now I can drag these down and they'll come out 0. And that's because I haven't actually given the program any good guesses for Km and Vmax. Km, as you can see on the graph, is the concentration where we are halfway to our maximum velocity, our maximum reaction rate. And you just take a guess at it. You think the data is going to bend round and it gives me a particular value. I'm intentionally picking bad values right now because Vmax, on the other hand, I'm going to guess is 500. There you go. It's now giving us some data. Next thing, oops, I did this in the wrong order. We're going to calculate the error. How much difference is there between our prediction and the average? The way we're going to do that is say equals average take prediction. We don't need $signs because we're going to move all of them down at the same time. So we've now got some errors. As you can see, pretty tragic, not great. What we need to do now is use a new formula. So sum square, sum SQ in this box here, to calculate the square sum. So it's going to square each of these error values and then add them up. What that's doing is helping us to get rid of this negative value. And we end up with a very large number. At this point, I could go in and I could manually start to change my parameters, and it will start to either increase if I'm getting it wrong or decrease my sum squared errors value. I can't see the difference here, not well. So what I'm going to do is I'm going to make a graph, which is substrate concentration versus average and substrate concentration versus prediction. Highlight my x-axis, press and hold Control, drag down across the two things I want. Go to Insert, Scatter, and then I'm going to spend a few seconds just making it look slightly prettier. Don't want my title on there right now. My prediction data, notice how when you click on your data, it highlights which one you're actually working with. If I right click, I can format my data series. I want to make it change the color. I want a solid line. Because this is a prediction, in principle, I could have any value here, which means it's not discrete, which means I can have a continuous line. And I don't want both, so I'm going to turn off my markers. So what we can see here is what's summarized over here with our square errors. This is a terrible fit. What we can now do is try using Solver. So go back to Data, click on Solver, and it will open up this Solver parameters box. We want to set our objective. Now this is choose the thing you are looking at to prove your fit is good. So in this case, we're using our sum of squared errors. We want to minimize that. And what we want to do is to get Excel to do what you just done by messing with our KM and our Vmax. So highlight both of those. And it is going to change these numbers. And every time it changes the numbers, it's going to see if the sum of squared errors is going up or going down. Each time it makes a judgment and it stops when it keeps making smaller and smaller changes and there is no impact on our sum of squared errors. So in this case, we're going to choose GRG nonlinear. As you can see, that's the default for this. And they are smooth nonlinear. We could, if we wanted to, add constraints, things like saying the Vmax has to be a positive number. But let's give it as little help as possible and see what happens. So once this is set up, you press solve. It thinks its thoughts. And what it's done is it has made 5 changes where the objective did not move. So it said, whatever answer I've come to, it's probably the right one. So we can click OK. And now that I've closed the solver box, you can see here that has made a pretty good attempt at the fit. So we've got a Km of 5.75 and a Vmax of 1336. And you can immediately see that this is a pretty good fit for this data.